Okay, good afternoon, ladies and Angel. What we're going to do is look at a particular triangle.
Yeah,
You don't have it?
no.
I'll get you one here. What do you notice about this triangle that I've drawn?
All sides are different lengths.
All sides are different length? Okay, that's a good observation. What else do you observe about it? Well, it'll come to us. We're going to say this angle here is 100 degrees. So that's going to be 100 degrees right here. Oops, 100 degrees. This angle here is going to be
50 and 30.
Let's make this 45. No, I want to do this. Here, I want to change this 110. Here. Wants to work out a certain way. I make this 110 degrees. And this one here is 40 degrees. And this one is going to be, let's say, and we know what this side over here is 21. And we want to solve for the unknown angle and the two remaining unknown sides. What would you think about given a problem like this to solve for this triangle?
Okay, probably degrees.
See.
Degrees would be easy. But I don't know about it's 30.
So 30 degrees. So if you subtract from 180, you get this, right? Okay, so that part of it's easy. But these sides here, how do we get these other remaining sides?
You can do it with tangent.
Well, let's look at tangent, because that's an excellent suggestion. Let's look at that.
Wait, do you have to do it if there's a 90-degree angle, or does it matter?
Well, let's just examine that, because Hannah, you're just really ahead of me. You're kind of taking Will's place today, maybe. No, you're Hannah, all right. So what happens is, if we use tangent, we could say tangent of 30 degrees is going to be our opposite side over the adjacent. Here's our adjacent side, 21. But if we want to solve for this side over here, I'm going to call this side little a, and you're going to realize in a minute, you realize that's not going to work, right?
Yeah.
Because of what you said. What did you say?
It's not 90 degrees.
No right angles. All right, so what we're doing in Precalculus now, we're evolving into how to deal with angles that are not right angles or non-right angle triangles.
Gotcha.
So we're looking for techniques for that, so that's what we're doing.
We need this one first.
Yeah, we did. There was some
There
questions
was one
about
like this and I had no idea what I was doing.
I didn't know.
Was there one like this?
Yeah.
guessed.
I didn't know they did law of sines.
There was one like this.
Really? Let me see here. Let me look here.
And
Yeah, but we
Mr.
couldn't
G,
use our calculator.
Mr.
It was-
G, on one of the no calculator questions, it says what is like 30 tan times like 25 or something like that.
Oh,
And we
okay.
didn't know.
And it was a non-calculator
Oh
one?
no, I did that with my fingers. The tan, where's the, yeah, and I had to do my hand. Your hand trick came, because we couldn't use our calculator, and it was like tan 30 equals what, and you had to pick the little things at the bottom, so when I did the,
And you figured it out and it worked out?
yeah.
Man, that is really awesome. But see, that's not actually a law
The
of...
no count section, no glue.
See, that's not actually one. Let me show you here. Let me get to the SAT math thing and see if it's there on the instruction sheet.
In the reading section, I got distracted.
Yeah. I heard the reading section was hard.
Yes.
Okay, let's see if they give, because this is what they give you on your beginning here. And yeah, they don't give law of sines here. Now, I didn't know law of sines was on the SAT. I know law of sines and law of cosines are on ACT sometime, but I didn't.
It was one like that, like
Okay.
what you're working out what that triangle
Wow,
was.
okay.
I remember I didn't know how to do it, so I set it up as like a proportion thing, and it wasn't the right answer, but I didn't know what to do.
Okay, well here, I'm sorry about that. So what we have here is we're going to introduce something to deal with non-right angle triangles, and there are two equations for that. The one we're going to start working with is called the law of sines. And I will tell you that based on what I saw from reactions during fifth period is I didn't see anybody who really remembers anything about it. And between Karina and Elizabeth and everybody else who's in the class, all right. What was I saying? Between Karina and Elizabeth, everybody's in the class. Somebody usually remembers things from geometry, but geometry was a long time ago, wasn't it?
Yeah, like 2 years.
Yeah, so that's a while. And so, but Mrs. Clausen, she says she's teaching it. Maybe she didn't teach it 2 years ago. I don't know.
No, she probably did, but she don't remember.
Possibly. Anyway, this is it. It's right here. It's going to be sine of big A over little a equals sine of big B over little b
Yeah, I
I
remember.
remember.
equals, so you remember now?
Yeah.
Big C over little c.
Oh,
So that's it. So that's the formula. And it's one that I'm going to let you have on your formula chart for every test you have in this class. But it's one that's really pretty easy to remember. And by the way, when you take the ACT, I think they do give you that formula. I think they put that on their formula sheet for that. Okay, so law of sines, and since these ratios are the same, what I like to do, if I'm trying, the thing where it works is if you have a known side opposite a known angle, that's evidence that you have a law of sines application. So what I like to do is I like to turn this equation upside down, and I'm going to label these angles here. I'm going to put little a, big A. I'm going to call this one B here, big B, little b, and big C, little c. And that's a convention, is that it's understood that your angles are going to be the capital letters, and your sides are going to be your subscripts.
But it doesn't really matter which one we put A, B, and C because it's all the same, right?
That's right, It doesn't matter how you label them.
they
Yeah,
just
they're
have to
really-
be across.
They're really interchangeable at how you use them. And that could really help you to figure things out easier. And so what I'm going to do is, this is my known side, and what I like to do when I do these is if I'm trying to solve for a side first, I like to turn these equations upside down. So I'm going to say I want to find, which one do I want to do first? C? So I'm going to say little c over sine c equals little a over sine a. That's what I'm going to use first. And so I have little c, which we don't know, over sine c, well that's going to be sine 40 degrees, is going to be equal to little, I want to put the b here is what I want to do, right? Let me fix that. I want to put b because b is the one we know, right? Little b over sine b. I'm making little mistakes here, and I promise you I'm doing them not necessarily on purpose, but they kind of serve a purpose. And then what you can do is you can cross multiply, and so you have little c is equal to 21 sine 40 degrees over sine of 110 degrees. And so that's going to be equal to, you go to your calculator. Does this look familiar from what we did yesterday a little bit?
Yes. For the
Okay.
second half of it.
Yeah, the part of it. So let's go do that. So I put 21 sine 40 degrees over sine, was it 110?
Yes.
So we have 14.365, is that?
Yeah.
So that's going to be one of our answers, and we already have this answer here, that angle A is equal to 30 degrees. That's another answer. And the last one we have is, so we know what C is over here. What do we need to know yet? A, right? So we take, again, 21 over sine 110 degrees equals A over sine 30 degrees. And so what that's going to be, it's going to be, we were solving for A, right? So what we have here is, we have A, so I'm cross multiplying sine 30 degrees, so I'm going to get 10.5 over sine 110 degrees. Any questions on that?
No, it's coming back to me kind of.
Yeah.
Nobody has a question about where 10.5 comes from?
Yeah, how'd you get 10.5?
How did I get 10.5? I knew that. Okay, remember Emma was talking about taking her SAT and remembering the finger tricks and all that, right? How did I get 10.5, Emma? I'll tell you. Okay, also the unit circle trigonometry song, 30 degrees, right?
Yeah.
0, so this is the thing, right? So 30 degrees,
Yeah.
sine square root of fingers over 2.
So square root of 3 over 2.
Square root of 1 over 2. So that's 1/2. So I know that's 1/2. So I can just cross multiply 1/2. And have that. So I'm trying to weave in. Pardon me? Oh, okay, well then, maybe we'll talk about. I'll talk about that later. So A is equal to
10.5
over sine 110. So 11.174. Okay, questions on that? All right, good deal. Let's get these exercises we'll start working on. All right. So what I want you to do is look at problem 1 and see if you can start working on problem 1 based on what you see up here. Do you look like you can do problem 1
Yeah.
based on that?
I got it for her.
So try to do that.
I can find my chalk.
You find your calculator. Do you have your calculator?
No, I'm using one on here.
Using one on here. Do you have a lot of signs on there? Do you have sign?
Yeah, yeah, I think I can use that on here.
You have sign on there?
Yeah.
You have sign.
Yeah.
Okay.
Yeah.
So you can do that, or you can borrow one.
Yeah.
A calculator here.
She got it.
You'll be okay.
She goes, she goes.
Kids, I know how you feel about interest now, because I know I'm gonna do the same thing for ag.
I literally was in a meeting on Wednesday and only one other person showed up. And I've already had 3 minutes, so I'm not gonna read it. really nothing else to do.
Is NHS a big deal as far as having a lot of work?
No. Well, a lot of work, yes, because I'm the only one doing it, Will and them do nothing.
Yeah, because you and Will are supposed to be the co-leaders
Will
of it.
does nothing.
Okay.
Because our secretary dropped out, so I have to do that job too.
Yeah, and then I can't do my service project as well, because the cost is way included. And
They
then,
didn't have the money either, so I just went off and did it on my own.
what did you do?
Tutoring kids, they wouldn't let me in the school because of COVID. So then I asked about doing the, like, Zoom calls, and they told me they wouldn't send out a Zoom link or any way for me
I
to
don't see how
contact the kids.
they can just say that when one of the girls says, Haley's doing it.
Because I was going to do tutoring for math, and they told me no, so then I started doing it by myself.
Okay, what I'm gonna do is I'm gonna choose somebody to help. I got a wheel of names here
Okay.
that I can choose, so go ahead and work at that. Just let me know when you're pretty much done with problem one. The rest of them are, like we have video class yesterday.
I'm done, Mr. Meeting.
You done? How's everybody else? Everybody done or close to it?
I'll have to stall for one more.
Okay, let me just wait another minute. And then wherever you are, you can just work with us. And okay. Okay, let's go here. We got, okay, spin the wheel here. What do we got? We got, it's gonna be Kayla.
A equals 4.531 and C equals 5.0.
Yeah, I didn't hear what you said.
A equals 4.531 and C equals 5.054.
So little a equals 4.531, did you say? And
C equals 5.054.
0.54. And this angle C up here,
75.
75 degrees. Okay, did everybody get that, or you have questions about that? I'm just gonna quickly write the,
On the A, it should be 32.
oh, it should be 432
Yeah.
because of the rounding.
Yeah, it's 1.5.
Okay, let me tell you, I want to tell you something about rounding here, according to AP standards. If it said 5.13115 something, they would give you credit if you put the first thing that you saw or the rounded one. So in that case, they would give you credit for 0.531 or 0.532. That's just a little quirk about AP test standards. So I can leave it up here like this. So we have is little a equals 3.7 sine 60 degrees over sine 45 degrees, right? Is that what you got for your equation? And little c is going to be equal to 3.7 sine 75 degrees over sine 45 degrees. Does that look right? Do you see where I got all those? Did you get the same thing?
Yes.
Okay, good. So we're good on that thing, Kevin. So you have, so you're working on problem 2, or you finished it? Hopefully you're working fast. Okay, good. That was fast. So probably for today is I want to see if we can get through 1 through 4. Okay, I'll actually erase it. Save it. Well, I'll erase that later. Okay, here we go. 2. And our next victim today is going to be Hannah. All right, Hannah, you got number 2.
Yeah, I got it.
All right.
For little a.
So little
Where it's 13.8a.
13.88.
And then for their big A, I got 45 degrees. And for little B, I got 5.08.
1.08. Okay. And so your equations for that were like,
I started with C.
you start with C.
Yeah, I did 17 over sine 120, and then I found A, and I got A over sine 45 and cross multiply by 5.
So C equals 17 times, oh, you already started with C.
Sine 45.
Hang on a second. So this 45 degrees here is what you're saying.
Yeah.
So you solve for A first.
Yeah,
So-
I saw her
so little
all
a-
first.
So little a equals
17
17 sine 45 degrees, right?
over sine 120.
Over sine 120. And little b,
And then I just used C again, and I did 17 times sine 15
sine 15.
over sine 120.
So that's how you got, okay. I want to tell you a mistake that I'll see students occasionally make, is they'll forget it. They'll go ahead and forget that it's sine. So they'll just pay 17 times 15 divided by 120. Does it surprise you? I've seen those kinds of mistakes. Yeah, so that happens. And then this one's 40, so anyway, that's it, right? All right, thank you. It's going to be Emma or Kinsey. It's Kinsey. All right, Kinsey. What do we got here for problem 3? Oh, can you use calculator? Calculator. You don't have your calculator? Oh, it's not, yeah, that happens. I know. That's that, I know that.
For lowercase b, I got 15.8, and lowercase c, I got 12.82.
15.8, and for lowercase c, you got 12.82. Okay. And so, does that corroborate pretty well with what everybody else has?
Yes.
It does. The only thing I'd try, if you can remember, to see if you can go to 3 decimal places on these. That's the only suggestion I would make other than that. Does anybody need to have these set up at all? Angel, are you good with this?
I think we are good.
Already did? Okay, good. Thank you, Kinsey. Let's go on, I'll choose somebody for number 4. I think we just, after number 4, we don't have drawings to work with. And so I kind of want to start with number 5 tomorrow. How's that?
That sounds good.
That's good. So I'll call somebody for 4 here. And
Don't say it out loud.
so we're going to have, we only have 3 left. It's going to be Angel or Emma. It's Emma. All right, Emma, give me a minute. Give me just a minute for help Kinsey here. All right, Emma. Qu'est-ce que nous avons, Emma? That's French, like, this is like today, this is like a combination French pre-calculus
I
class.
don't know French.
Qu'est-ce que nous avons means what do we have? What do we
I
have?
added the 40 and 81 and then subtracted them from 180 and got 59 for C.
So 59 degrees, okay.
And then I did solve for little c, and I did
So C over sine 59 degrees, right?
yes. Is equal to 92 over sine 40. And I got 122.
So little c equals 122,
0.683.
0.683, okay.
And then for A,
So little a,
A over sine 81 is equal to 92 over sine 40.
okay, so that's gonna be,
141.364.
so that's that, and that all solved, okay? Any questions on that? All right.
That's pretty easy.
Yeah, quite, so really this should be pretty easy. You remember working
Like a
pro,
refresher.
so you remember that now from 2 years ago?
Yeah.
Okay, all right, good. I know Mrs. Clausen is gonna be happy to hear that when I tell her